Imagine waking up one day and discovering that Earth has become almost impossible to live on. Fresh water is disappearing, plastic is everywhere, extreme weather is becoming the new normal. Now, imagine. The technology to stop all of this already exists, but hardly anyone is talking about it. For decades, we've heard the same warning: climate change, water shortages, ocean pollution, carbon emissions. It often feels like we're running out of time, but history tells us something interesting. Whenever humanity has faced its biggest challenges, technology has changed the rules. And today, scientists around the world are building inventions that could completely transform the future of our planet. Some of them sound like science fiction, others are already being tested today. But here's the surprising part: none of these technologies can save the planet alone. Their real power comes from working together. And the first one could solve one of humanity's oldest problems: the lack of clean drinking water. More than 2 billion people around the world experience water stress during at least part of the year. At the same time, over 97% of Earth's water is salty and cannot be consumed without treatment. Traditional desalination plants can produce fresh water, but they consume enormous amounts of electricity. Now imagine replacing fossil fuels with sunlight. That's exactly what solar desalination aims to do. These systems use solar energy to evaporate seawater. The water vapor is then condensed into clean, drinkable water, leaving salt and many impurities behind. Researchers are also developing compact, solar-powered desalination devices for remote villages and disaster zones where electricity is limited. If these systems continue improving, they could provide clean water while reducing energy use and emissions. Clean water is only one part of the problem, because even if we solve water scarcity, our planet still faces another enemy, one that never seems to disappear. It's plastic. Every year, millions of tons of plastic enter our environment. Some plastics can take hundreds of years to break down naturally, but scientists have discovered something remarkable. Certain enzymes, including one known as PETase, can break down PET plastic, the material commonly used in many drink bottles and food packaging, much faster than natural processes. Researchers are now engineering improved versions of these enzymes to make recycling faster and more efficient. Imagine future recycling facilities where plastic waste is broken down into its building blocks and reused to create new products instead of ending up in landfills or oceans. It's not a complete solution yet, but it could fundamentally change how the world deals with plastic waste. But cleaning up yesterday's pollution isn't enough. What if technology could actually predict tomorrow's disasters before they even happen? That's where artificial intelligence enters the story. What if a computer could predict a deadly flood days before it happened? Or warn farmers about a devastating drought months in advance? That future is already beginning. Climate disasters are becoming more frequent: floods, wildfires, heat waves, and hurricanes. But artificial intelligence is giving scientists a powerful new advantage. Modern AI systems can analyze enormous amounts of data from satellites, weather stations, oceans, and historical climate records, far faster than humans can. By recognizing hidden patterns, AI can improve weather forecasts, estimate wildfire risk, predict flooding, and help authorities respond more effectively. It's also being used to help farmers decide when to plant crops and to optimize renewable energy systems based on expected weather conditions. AI can't stop a hurricane, but better predictions can save lives, reduce damage, and help communities prepare before disaster strikes. But even if we stop future pollution, there's still a mountain of waste already floating through our rivers and oceans. And that's where the next technology takes over. Every year, millions of tons of plastic enter the world's oceans. Some of it breaks into tiny microplastics that are extremely difficult to remove. To fight this growing problem, engineers are developing autonomous cleanup systems. Some robots patrol rivers to intercept trash before it reaches the sea. Others use floating barriers and collection systems to gather plastic already drifting in the ocean. Researchers are also exploring AI-powered underwater robots that could identify waste more efficiently in the future. These technologies won't solve ocean pollution on their own. But combined with better recycling and reduced plastic use, they could dramatically reduce the amount of waste reaching marine ecosystems. But removing plastic is only half the battle. The invisible threat is something we can't even see: carbon dioxide. And scientists may have found an unexpected ally: tiny, living organisms. Some naturally occurring microorganisms already consume carbon compounds as part of their life cycle. Scientists are now studying and engineering microbes that can capture carbon dioxide and convert it into useful materials, such as biofuels, chemicals, or biomass. If these technologies become commercially scalable, future factories could reduce emissions while producing valuable products at the same time. Instead of treating carbon as waste, we may one day treat it as a resource. But what if our buildings could repair themselves, and giant machines could pull carbon directly out of the sky? The last two technologies might sound impossible, yet they're already moving from research labs toward the real world. Imagine driving across a bridge, and tiny cracks begin repairing themselves automatically. It sounds impossible, but engineers are already making it happen. Concrete is the most widely used construction material on Earth, but once cracks appear, water enters, steel rusts and buildings weaken. Repairs cost billions of dollars every year. Now imagine concrete that repairs itself. Researchers have developed several self-healing approaches, including materials containing bacteria that produce limestone when water enters cracks, as well as capsules filled with healing agents that seal small fractures. These technologies are still developing, but they could dramatically extend the lifespan of bridges, roads, tunnels, and buildings. Less rebuilding means less cement production. And since cement manufacturing is responsible for a significant share of global carbon emissions, longer-lasting infrastructure could also reduce environmental impact. Sometimes, saving the planet isn't about building more, it's about making what we build last longer. But what if we could go even further? Not just reduce emissions, not just recycle waste, but actually remove carbon dioxide directly from the atmosphere. That brings us to the most ambitious technology on this list. For more than a century, human activities have released enormous amounts of carbon dioxide into the atmosphere. Even if emissions stopped tomorrow, much of that carbon would still remain. That's why scientists are developing direct air capture systems. These machines use specialized materials to capture carbon dioxide directly from the air. The captured CO2 can then be stored deep underground or used in products such as synthetic fuels, building materials, and industrial processes. Several pilot projects are already operating in different parts of the world, although today's systems are still expensive and energy-intensive. They're not magic machines, but as technology improves and costs fall, they could become one of many important tools for reducing atmospheric carbon. Think of them as artificial trees, built by human hands. Every generation faces a challenge that seems impossible. For our grandparents, it was world wars. For our parents, it was the digital revolution. For us, it may be protecting the only planet we've ever known. None of these technologies is a miracle. None of them can solve climate change alone. But together, They represent something incredibly powerful: human ingenuity. The future won't be saved by one invention. It will be shaped by thousands of scientists, engineers, entrepreneurs, and ordinary people willing to adopt better solutions. The real question isn't whether these technologies are possible. Many of them already are. The real question is, can we build them fast enough? If one of these innovations surprised you, tell us in the comments which technology has the greatest potential to protect our planet and why. If this video gave you a new perspective, leave a like. It tells us these deep dives are worth making. And if you don't want to miss what's coming next, consider subscribing. Subscribe to Tech Money Decoded and join us as we decode the technology that will define tomorrow. See you in the next video.